In our first example, we would like to know what is the mass in grams of 1.5 times 10 to the 21st molecules of aspirin, which here's the molecular formula. So this is going to utilize Avogadro's number to convert from molecules to grams. So first, we need to know the molecular weight. So we need to calculate this up. So it will be 9 times the molecular weight of carbon, which is 12.01, which you can get from a periodic table, plus 8 times 1.01, which is the molecular weight in grams for hydrogen, plus 4 times 16. When we plug this into our calculator, we have 9 times 12.01 plus 8 times 1.01 plus 4 times 16. That gives us 180.17 grams. Now, we want to convert this value, molecules, into grams. So 1.50 times 10 to the 21st molecules. So Avogadro's number tells us how many of anything, elephants, states, pecans, there are in 1 mole. So there are 6.022 times 10 to the 23rd molecules in 1 mole of aspirin, which is C9H8O4. Now we have the molecular weight, so we know in 1 mole of C9H8O4, we have 180.17 grams. So when we plug this into our calculator, we have 1.5 e to the 21 divided by 6.022 e to the 23rd. We're going to multiply that by 180.17, which gives us, running out of space, 0.44878 grams. Now, this feels like too many significant figures. Let's double check. So there are 3 significant figures in this value, and so our value needs to have that as well. And so we have 0.449 with significant figures. Okay, in our next example, what is the molar mass of diazepam, which is a drug, if 0.05570 moles has a typo, a mass of 15.6 grams. So this is set up a little bit different. It's a little tricky, but we know that molecular weight is grams per mole. So if we have moles and grams, what about if we just solve for this value? So if we have 15.86 grams is equivalent to 0.05570 moles, we can divide those two numbers. And we get a value. So we can determine that 284.739 grams per mole. Now we do have too many significant figures, likely, so there are 4 in this value and 4 in this, so we need to trim this. So if we use our sig figs, we can determine that there are 284.7 grams per mole. Now this doesn't allow us to determine the molecular formula of diazepam. There are other ways that we could do that, but that's not part of this problem.